Good evening, friends. Today we will start functions. Functions, we have heard this word right from the day one, that is main function, right? So, what we are going to learn in this chapter? First of all, C program, rather C programming language, it has got many terms stick to that C programming language. Like C is called a structured language, C is called a modular programming language. C is also called as a procedure-oriented programming language. So a lot of these terms are stick to that. Meaning of all these terms are same. We will term it as a procedure-oriented programming language, POP. Here, what I mean by procedure-oriented is procedure is a small code which we call in C language, which we call it as function. So we can say it as a function oriented programming language. Really, is it a function oriented? So answer is yes. It is really, in a true sense, it is a function oriented programming language or a procedure oriented programming language. Why? Because when you write, first of all, a program, the execution of the program starts from the main function. So it is a function. When you want to give some message to the user, you think of calling printf. What is that? Again, it is a function. The moment you think of taking some input from the keyboard, very next moment you think about scanf function. So that is again a function. Then there are numerous functions. We have not started using them, but recently we use that function fflush. Fflush, right? Fflush. That is also a function. Okay, all these are, I agree that all these are library functions. But you take help of some functions or you take help of some predefined, pre-written codes which are already available. So you take help of all those functions and you write your own function. So it is a collection of functions, you can say. In a true sense, it is not collection, because collection means each function will be a separate. So it is not like that. Though each function is separate, we call that function from some function, right? So that is the reason we call any C program as a collection of functions. I have reiterated the fact that execution of C program always starts from the main function. In the past, I have already said that any C program must contain one and only one, not one and only one main function. So it must contain. So again, it is a function. You have learned that set theory perhaps, and I think you can recall in the school days, right? So we used to take intersection of set, right? Set theory. So whichever sentences, whichever statements I have said, in each statement you can find easily a single word which is common to all, that is a function. So without function, it is very difficult to write C program. Now, functions in C have got two categories, first of all. So one is these will be basic terminology what we are going to learn. So we will see what is function. Okay, what is main function? That we have already used that. So there are two categories of functions in C. One is a library function, other is a user defined functions, right? We are going to study in this chapter how we can write our own function, that we call it as a user defined function, because function is no a sequence of statements. Obviously these are logically a logical sequence, and we close that inside a pair of curly braces. What we call it is the body of the function. And before opening curly brace, there is some function name. No, so far we have used only main function. So it is to be a main, then opening and closing brackets or parentheses. And then there used to be a function body, right? So that we call it as a function. In our day-to-day life, uh, these days, basically, in last 5 or 10 days, I think after the rise of social network, I do not remember exactly from where that a typical culture creeps in a human's life. But in earlier days, no, whatever I'm going to say, take it lightly, right? But that is my observation. Last 5 days, 10 years, I think there is it. There is a typical, what you can say, sentence, okay, used by young generation almost as soon as he passed out and get the job, or he is settled or some kind of thing. Okay, so they use the sentence that I am independent, right? Okay. Nowadays, even he hasn't got the job, even though he takes admission in the college. Okay, he says that I am independent. One has to introspect, rather everybody has to introspect. Really, a man can be independent. Okay, the answer is no. Nobody can be independent. Okay, because we depend on a lot of, no, we depend upon, first of all, lot of uh, we depend upon family members. You depend upon society. You depend upon each section, whether it is a small or a big, whether it is a minor or a major. So all sections of society you depend, be it a rickshawala, be it a iron man, be it a bakery, be it a, no, anybody, be it a bus, a train, okay, be it a jhaduwala, okay. So everyone, you depend on that. So one should not say that once he starts earning, I am independent. Okay, you are just paying. That's it. Okay? You are paying for some service. But don't forget that you are dependent on that. Right? So, but that is the generation how, okay, behaves like that. Why actually I said correlate that along with programming. Okay, consider C programming. The Dennis Ritchie says that my C program would be a collection of functions. So we will be depending on other, right? So it is a basically Dennis Ritchie has put forth a very important philosophy of a life. One has to learn any programming language from philosophical point of view, not just syntactical point of view, right? When you say like that, I am dependent person, that is good basically, because you you get rid of your ego, okay, which is very dangerous. That is different story altogether. I don't know whether your teachers teach you in this fashion or not, but I used to teach. I used to teach, I used to say something apart from the our technical aspects of any programming language. What I mean is we are dependent. Similarly, C program, while writing C program, you are also dependent. So when you think of you're depending on some, you are dependent on somebody, something, some agency. What does it mean? It means that that agency is expert in that. So you are dependent. Okay, dependent. Suppose you have got a vehicle. You say that okay, and basically I have observed many software engineers in Pune and no Bangalore, okay, earning somewhere around 2 lakh rupees per month, and they say I'm completely financially independent. Okay. But what happens while going to the office or while going on the weekend? Their uh, their four wheeler tire got punctured. Okay, it goes flat. What he can do, he has to approach some that person to get that repaired. It has got some vehicle has got some engine problem. He has to approach that mechanic who is a specialist. He cannot become mechanic, right? He has to approach that mechanic. He has to approach that iron man. So a lot of agencies are there. Why actually I'm telling you why we write user defined functions? Because when you write some functions you can use them again and again, right? So we will be writing our own functions, and we are going to see how these functions can be written, how these behave, what should be syntax, okay, what care should be taken. That everything we are going to take care of in this chapter, and we have to learn from that angle. Next is function call. What is a function call? Right? Students get confused between function call, function definition, function prototype, and all these terms are various terms are there. So there will be function call, there will be function definition, there will be function prototype, there will be written type of a function. Lot of things are very important when when you master all these things. Lot of programming language in the future you are going to learn. Second year, third year, last year, or even after finishing your last year. Even Python, Java, .NET, lot of programming languages are there. This chapter is going to help you a lot because you need to understand that philosophy, that's those syntaxes and how they work. That is very important, right? Then what are actual arguments and what are formal arguments? All these terms are used in these days most hyped language, that is a Python. All these terms are over there. Little difference is there only in the term, but meaning is same. So we will be learning all these terms. So first of all, what are features of main function? I have actually said about that, right? There can be only one function, one main function. There cannot be more than one main function in any C program. There can be many functions in any C language, right? What we have used so far is library function. This is a procedure oriented programming language. Okay, it is also called as a modular programming language. So what I said, that is in front of you in the form of a slide. Let me finish slides and then we will directly write programs and now try to learn all the important concepts in functions in C, right? So let me finish all these things. Then parts of functions, we will cover all these function prototype, definition, function block, return type, actual arguments, formal arguments, and call stack. Call stack is very important. Usually it is not taught. Part of that I have already. And again, return type of a function, return type of user defined function, very important. Returning values and intricacies of return. So these lot of terms are there. While writing program, I will talk about each of these statements. If anything is missing, that will be covered in the programming, right? So first of all, let me open the whiteboard. I think it is visible now. Whiteboard is visible now. So this is your C program, right? So there is a main. You used to write as int main, and this is the body of the function, right? This is the body of the function. I told you that this this defines the body of the function. That is why it is very important. Opening and curly, it defines. Okay, it defines the boundary. At the same time, I told you, I think last time, storage classes as well as preprocessor directives, when you declare variables, variables are pushed onto the stack, right? So when you declare variables, three variables or four variables, there will be x, there will be y, there will be z, there will be num, right? So all these are pushed onto the stack, provided these are auto variables, local variables, declared inside functions. You should actually be able to recall all this, what I taught you in the storage class. Because while teaching these functions in C, I will be referring to storage classes as well as preprocessor directives, right? Interchangeably. Hmm. Now, at the same time, I told you that I taught you one program, I think static variable, teaching you local static variable. I wrote one function, right? At that time, I taught all these things. So this is basically a stack for the variables. Similarly, there is a stack for functions, right? So when control goes inside the main function, right? This main function is pushed onto the stack, right? So there will be a main. So if you call some function, okay, that will be pushed onto the stack. So there is the stack is maintained also for the functions as well, right? And each function has got its own stack like this. This function is maintaining its own stack for variables. So, and this is basically called a call stack. I mentioned the use call stack. I think I use this term while teaching you storage class, but this is called a call stack. While writing programs, I will show you this, right? But most probably during okay, I will show this in this chapter as well, right? So this is called a call stack. Call stack is stack maintained by the compiler for calling functions, right? There is a stack pointer as well. One more concept is there. I think as a computer engineer, you must be aware about this. This is called a stack pointer. Stack pointer is internally maintained by the compiler so that it can call the functions, right? So this stack pointer moves in this direction as well as this direction, right? This is like this. Stack pointer is like this. Okay. So when main function is called, the pointer is here. Okay. When another function is pushed, okay, this pointer moves here. This pointer moves here, right? Then it moves here. So likewise. So this is how the stack is maintained by the stack pointer, right? Now our concern is we have already used that printf and scanf. Our concern is how to write our own functions, right? So we will start writing programs directly, and in that program, I will teach you everything, right? This is just basics I taught you. So when I say that C programming is a collection of functions, it means that there will be no separate function bodies like this, right? So this will perform its own task, small functions, right? These will be small functions which are perform some small tasks. Right? When you want to get some work to be done, instead of doing it here, you will call the function, right? You want some task to be done here, you will call the function. You will call, you want to get some down, you will call the function. Okay. So whatever the code you have written here, right? Whatever the code you have written here, whatever the code you have written here, okay, you don't need to write it each time. You will just call the pre-written function. So we want to learn the basics, right? So what we will do, we will write function and we will call it. That's it. In the real life, what will happen? This function will be written by somebody, your superior or those who have joined in the company before you actually join. Okay, so he will tell that this function is ready. You can call it, right? So when your superior, your boss, your teammate, when he actually tells you that this function is ready, okay, you don't need to write code for that on your own. Okay, it is the functionality is ready. You just call it. So at that time, you should understand the meaning of that when he says you can call it, because when he says that you can call it, you should call it the way it has to be called, right? It has to be called. Like suppose you know that in programming world, when you call the function, it has to be called the way it has to be, right? Otherwise, you cannot call that function. Okay. When we write programs, yesterday I tried to call that system function. Could we call it? No, because system function is there, but it gave an error only because there is some method to call that. Okay, and I failed to send the arguments. Okay, the arguments which that function is accepting, function is rather expecting. So that function body is inside the. Okay, so what I mean, there is a some function in the library, right? This is the library. Okay, there is some function. Okay, it is a predefined function. So there is some function like main function. There is a some function like system whose name is system, right? Like main function is body is like this, right? And it takes some arguments. Some argument is there, right? You need to send these arguments. Then only this function will be called, right? When you call this function, this code will be executed, and you get the result. Now, why it gave an error? Only because we failed to call it the way it has to be called. We didn't follow the rules. So we will see all these rules, right? Fine. Try to understand all possible features. Right? First, let's write very simple program. So I won't declare any variables. I will write just what was there. It was there hello world. Okay. So before that, I will write here printf. I'll write I am in the mean, right? Right. Now I will call some function. Call some function, and I will call another function. Right? So what is this? This is called a function call, right? Like this. This is also a function call, but this is a library function. This is also a function call. This is a library function. Similarly, this is also a function call. So how do you know that? How you can recognize that? You can recognize there is a function name, there is opening and closing curly brackets, so pair of brackets is there, and it is followed by semicolon. Same function name, brackets is there, sorry, pair of brackets is there. Okay, whatever there inside this, we call it as arguments. Function can take argument, function may not take argument. Depends. Okay, there may be some functions which do not take any arguments. There might be some functions which take arguments, right? Whatever you write inside that pair of brackets, we call them as argument or parameters. Python language use the word, I think, parameters. Java, C++, C, these languages use the word as arguments. Now, we will see how these arguments can be written and everything, right? So this is also a function call. I will write here something, printer, right? I am again back to the main, right? Something. We want to just check the flow of control. I'll write here printer main, right? So we don't need to write the definition of this function because it is library. This is also library, but some function is not defined in the library. So we need to write the definition of that. So I will come to that. What is definition and all this thing? So there will be some function, right? This is definition. The definition is just like a main function. This is the definition of main function, right? So this is just one more function, user defined function. So its body will be similar to the main function. Okay, name will be different. Okay, the name of this function is main. The name of this function is sum function. That's it. Okay. Now I'll write something here. I'm inside sum function. And put the bracket. I will not write anything here. Just single statement. One more function is there. Another function. So I will write here. Right. Here another function. Right. So if I run this, if I build this code, let's see whether it gives some errors or warning. Yeah, warning will be there definitely, right? I will talk about these warnings later on, but as far as execution of the program is concerned, there won't be no, I think there would be no any problem, right? Let's execute that. Okay, so program is executed. Okay, for time being, we are ignoring the warnings, but even that program don't ever ignore warnings. So how this program is executed? When control goes inside the main function, because execution of the program starts from the main function. Okay, so this output proves it. Okay, I'm in the main function is executed, it's printed first. Okay, because it is line number 6. Then hello world is printed, right? Because it is a sequential control structure again. Then some function. So some function, when control reaches at this line, we'll remove this. Okay, let it be there. When I remove this, when this statement, when control comes at statement number line number 8, This is a function call. So control transfers, right, from this function to function body. So here is the function body, right? Likewise, when control comes this statement, printf function is a library function, so it is not here, but it goes from the control jumps from this main function to body of the printf function inside library. When control reaches here, the control jumps from this function to this function, right? And that is why it shows that I am inside some function, right? I am inside some function. So this is executed, right? But what does the control does afterwards? It goes to the point from where it has been called. Okay, so it will reach again here. Not that it will reach again here, and then it goes here. That's why it will give output as I am again back to the main function. Then again function is called. So control goes here, function is called, control goes here. This will be executed. So that's why you get the output as I am inside another function. Again control goes to the this point from where it has left, right? It is like a bookmark in your book. When you read that, okay, you are reading some novel, okay, you are particular at some point, right? You put their bookmark. If somebody actually calls you or phone, no, phone rings or anything, any interruption might be there when you read the book. I don't know whether you read books or not, but if you are, suppose you are reading book, okay, you come across particular word or a line or a page, whichever, so you put that bookmark and you go there. You jump to the another activity. You finish that, come back and resume your reading from that point. But to resume that, you have to come to that point. Same thing is here, right? So it comes at that point. Now, how does it do all these things? Okay, it does all these things with the help of call stack, right? I will show you that. Okay. Now the cursor is there only because the cursor is on the output window. Cursor is blinking. Why? Because control has reached to the line number 6, because I showed you that yellow marker shows reflect that it is the point where control has reached, right? So now uh, I will press I will not press step into. I told you that as far as library functions are concerned, don't use step into, don't go inside that function definition, right? So at that point use the next line. Okay, so I will use the next line. So control goes to the next statement. By this time, what happened? Control goes inside this function, okay, in the library. Okay, that function is executed. Whatever code, maybe we don't know how many lines of code is there for the printf function. Maybe 50 lines, maybe 100 lines, maybe 500 lines. We do not know that, right? But since that function is executed, you get the output. I am in the main function, but the other output is yet to be, because it has not executed, right? So now control has reached printf. Again, another printf function is there, right? So again, I will push the next line, right? So it has printed that. Where is that? What happened? Okay. Okay, I think because of that bookmark. Sorry. Okay, finish that. Some abrupt stuff. Okay, I will put the cursor here and I will press the run to cursor. Okay, so here it is now. So line number 6, I will say next line, next line. Now control has come to the line number 8. By this time, two statements have been printed, right? I am in the main and hello world, right? Now, what I want to show you is that if you go to here and debugging windows, there is a call stack, right? So this is a stack maintained, what I showed you on the whiteboard. Okay, this is a stack, right? On the stack, main has been pushed. Only one main function has been pushed onto the stack. So this is a stack which contains only one entry, right? Now, fine. Now, uh, I will here. I will not use the this is our user-defined function. So I will not use the next line. I will use the step into. So when I press this step into, carefully observe this yellow line, yellow pointer, yellow arrow jumps from line number 8 to line number 14, right? See this carefully. And at the same time, look at this window, call stack. Okay. So I will use the step into. Got that? What happened? The control goes, okay, control goes inside, not line number 14. It is a function definition. So it control goes at the line number 16, enters inside function definition. And the some function has been pushed onto the stack. So main is there on that top because stack works like that. Some function has been pushed. Okay. But this line is yet to be executed, right? So I will now here, since it is a printf, I will not use step into, but I will use the next line. Okay. So control is now exiting. It has not yet exited. Okay. So I am inside some function that, but control is on line number 17. So I will go and put step into, right? So just check where the control goes again. It will go not exactly line number 8. Okay, it will go to the 9 number line because line number 8 only function call is there. Okay, what I mean by only function call in the next program I will explain you. Right, not at this, not in this program. But however, like in the earlier case, just when I press this step into, carefully observe pointer as well as call step. Okay, so observe carefully. What happened? Control goes to the line number 9 and this is popped. Okay. So this function body was created inside the memory and removed. Okay. From the call stack, nothing is there now. Right? Nothing is there. Whatever code is there, nothing is there now inside the memory. Right? Again, here printf function. So I will go to the next line. So this is again printed. You can see that I am again back to the main function. Again function is called. So line number 10, it will jump to the line number 20, right? So I will step into. So another function has been pushed onto the main now, right? Again, this will be executed. I will go to the next line. Okay, step into. Now it has again back to the main function, right? This is how it is executed. Okay? This is how call stack is, manages control flow of the functions. Control flow of the functions, right? This is very important to understand. This is the first step for understanding basics of functions, right? This one should understand before writing functions, right? Okay, I will terminate this, right? Okay. So I hope basics of functions you have understood. Know why warnings were there. Warning was there only because you have defined this function, right? Likewise, you have just called this function. There is no difference first of all. You have called this function which is inside the library. You have called this function which is in the same file. Okay. So no difference is there. But for this function, you don't get any error. But for this function, you get an error because this function has got is has been defined in the library stdout.h, right? It is defined. I showed you stdout.h, right? And I have taught you that where is that? I taught you the preprocessor directives, right? So here it is a printer, right? This is a printer. So what is it called? This is called a prototype of a function. Prototype or a function declaration. Since this file has been added, I hope you can recall all the preprocessor directives. Since this file has been included by preprocessor in our program, all this code is there. What we call it is the expanded source code. So this statement is there, okay, in our program. Since this statement is there, it doesn't give any warning for the printf function, but it gives warning for the sum function because declaration of this function is not there. Declaration of another function is not there. So how will you declare? You will declare here. What is declaration? Or a declaration is a prototype. What is a prototype? Prototype is just intimation to the compiler about basic information of a function you are going to call. What is the basic information? Right here. Function prototype is what? Name of the function, type of argument, number of argument, and return type. So you need to give here name of the function. What is the name of the function you are going to call? Some function, right? This is the name of the function. Type of arguments and number of arguments. As far as this function is concerned, we are not sending at all argument. So there is no question of type of argument. So it is empty, right? And what is the return type of that function? Return type is, this function is not returning anything. Okay. So you write here void, right? And since it is a declaration, since it is a prototype, it has to be terminated by semicolon. We have written this declaration same fashion like that written by the library developers for the printf function, because it was also terminated by semicolon. Okay, printf function was taking some arguments, so it was something there inside. Name of the function was there as a printf, and it was returning something. Okay, here our function is not returning anything. Similarly, on the second function, what is that? Another function. We need to write void another function taking the argument terminated by semicolon. These two statements inform the compiler, intimate the compiler that I'm going to call some function, I'm going to call another function. These two functions I will be calling. Rather, I may call. This function is not taking any argument. Another function is not taking any argument. Some function is not going to return anything. Another function is not going to return anything. This is how you are intimate compiler. Compiler is ready, right? Okay, as far as C language is concerned, it gives you warnings. Okay, as far as C++ is concerned, it doesn't give you warning. It does give you errors. Okay, it will not let you to. So as far as C++ is concerned, many students do not know this, right? Because they don't understand C, so there is no question of understanding C++. So in case of C++, function prototype or a declaration of function is a must. Otherwise, it will give an error, right? Now, whatever warnings were there earlier, okay, all these will be removed, right? This, okay, we have not modified that yet because you have written here void, right? You have to write here void. Write here void. Now function prototype and function definition, everything is fine. So you won't get any warning. Rather, you should not get any warning. Is there any warning? No. So warnings are removed, right? So you can run this code. Fine. So I hope you understood that function prototype, right? So this is function prototype, or it is also called as a declaration. Now, I will share. I have recorded today's session. I will share it along with you after editing that, right? So thank you very much.